guys. Okay, so 4.3 exponential functions. Exponential functions is something like 2 to the x power, 5 to the x power, 7 to the 2x power, something like that, okay? Where the variable is the power and a is a real number, not 1. Because if this is 1, 1 to the anything power is just 1, so that's not exponential anymore. Okay, so keep in mind, and don't get confused with the power function. This is a power function. X to the 7th power would be a power function, where this is like a number greater or equal to 2. This is not a power function because it's something to the x power instead of x to the something power. Okay, so just don't get confused between exponential versus power function. All right, so this is not something that you have to memorize, but it's kind of interesting and it's true. So there's this theorem that says for every exponential function, a to the x power, this should be true. F of x plus 1 divided by f of x equals a. Let's see why this is true. Okay, so why is this true? So let's go ahead and write that in. And then go ahead and plug x plus 1 into here and see what happens. It looks something like this, right? And then if you have the same base, a and a, what do you do with powers when they're divided? You subtract, right? So wouldn't that give you just a to the first power? And there's our little happy face. So see, we can prove something like that. I just wanted to show you why it's true if you see it again, okay? And you can always check something like that. You don't have to be like, true, false. Oh, did I memorize it? You don't have to memorize it. Okay, so graphing exponential functions. For graphing exponential functions, there's two parts that we want to focus on. Either this either this base is greater than 1, or the base is between 0 and 1, okay? So either we have like a 2, a 5, a 7, or we have a 1/2, a 1/5, a 1/7. So basically, is it a fraction or not? So if it's not a fraction, then let's go ahead and graph something like this. You guys know what exponential functions look like, but basically if you were to plug in a 0, you would get 8 to the 0 power, which is 1, so 0, 1. And let's say, you know, this is a 1, then you would have a to the first power, which is a. So I don't know where a is, but we're going to say it's like over here. So here's a as a y value, okay? Something bigger than 1. We don't know where it is. So 1 comma a, and then what if you plugged in -1? If you plug in -1, you would have a to the -1, which is 1 over a. 1 over a is some sort of fraction between 0 and 1. So we put it somewhere down here. So you guys know exponential functions generally look like this. They are curved upwards like that if this is a positive in front, and if this is if that's a positive in front, okay? So basically, and you know, right now with the coronavirus, everything, so this is your exponential function. We're always trying to make this exponential function start to swoop down. So we're trying to change it so it swoops down. Anyway, this is an exponential function. All right, what's the difference between that and something like this? Okay, well, if you plug in, let's say a is between 0 and 1, let's go ahead and plug in and see why this is true, okay? You still plug in 0 and you get 1. No matter what, when you plug in 0, you get a to the 0 equals 1. But now if you plug in a, and a is less than 1, so between 0, if you plug in x and a is less than 1, so let's pretend it's like 1/2, okay? So if this is 1/2 and you plug in 1, well, 1/2 would be like less than 1, right? It'd be down here somewhere. And then if you plug in 1/2 and then you plugged in -1 up here, 1/2 to the -1 power, you would flip it and get a 2. So then it goes up here. So see how an exponential function can go down. So this is a decreasing exponential function. This is an increasing exponential function, okay? So what are the difference between these in terms of all of our like, I'm missing words here, guys, sorry. I want to say factors. They're not factors. They're not variables. But like all of our defining like material. How about that? So what is the domain? You can see from left all the way to the right, it's all real numbers. So we write it this way, from negative to positive infinity. What about range? Well, it seems like, I mean, logically, is it ever going to get underneath there? If you do like 5 to the x power, can you get a negative? Is it possible to get a negative if you have a number to the something power? How would you do that? 5 to the what power would give you a negative? Nothing. You can't, right? So even if you had a fraction here, that would just be a radical. That would be a small, small number. So really, your range goes from 0 to positive infinity. So we're starting here. So there's actually this horizontal asymptote right there. So what is your y-intercept? Well, your y-intercept for both is going to be 0, 1. What about your x-intercept? There is none, because it does not, these do not touch the x-axis because there's a horizontal asymptote there. And then yes, there is a horizontal asymptote at y equals 0. And then as x approaches negative infinity. So y equals 0, if we were to write this as a limit, it would be the limit as x approaches negative infinity is y equals 0. Technically, there's a horizontal asymptote anyway, but if you wrote the limit as x approaches positive infinity, what would y equal? It would equal positive infinity. And then see how this one, the limit as x approaches positive infinity is 0, but the limit as x approaches negative infinity over here would be infinity, okay? But the horizontal asymptote is this. So still, no matter what, this is your answer for horizontal asymptote. So I'll underline that one, okay? Vertical asymptote, there is none. So actually, it goes to the right very, very slowly, but it does go to the right. This goes to the left very, very slowly, but it does go to the left, and it goes up, up, up the whole time. It just goes to the right very slowly. Okay, and then is it increasing or decreasing? You can see this one's increasing to the right, this one's decreasing to the right. Okay, both graphs are one-to-one functions. We can see that. Yep, pass the vertical and horizontal line test. Both graphs contain 0, 1, 1, a. See, this is still 1, a. This is 1, a. A just happens to be a whole number here, bigger than 1, and a is a fraction here. And both graphs are smooth and continuous. Smooth and continuous. Okay, so right here, it's how do you graph? So to graph an exponential function, you're going to make a t-chart with at least 3 points, and then you're going to do your transformations, basically. So, for example, let's say you have something like this and you're like, what the heck? What do we do? Well, what is the parent function? You have to specify the parent function is y equals 3 to the x, right? Because it's really something, 3 to the x power. All right, well, what's the 2? The 2 is a vertical stretch, so 2 times y. What is the 4? The 4 is a horizontal shift to the left. Oh, sorry. Do I have that? Oh, I have it here. Really, these should be switched. Yeah, sorry. So these should be switched. This one should come first. So, because we always go from left to right, okay? So this should be a horizontal shift, left 4. I would actually write it as x, minus 4. And then this one I would write as y plus 5, right? So the plus 5 is your vertical, oh, why did I say down? What is wrong with my notes? Jeez. Up 5. How terrible. Up 5. These are notes that nobody usually sees. They're just my notes. Okay, so let's go ahead and graph. You absolutely positively need graph paper for these, okay? You need graph paper for these. So print out some graph paper if you need to, all right? Okay, so if you're gonna graph something like this, you need to specify the parent function. And then once you specify the parent function, you're gonna draw a little XY chart. In your XY chart, you are not going to fill in the X values. Wait, are you? Yes, you are going to fill in the X values, sorry. What should you use for your X values? You can use, I'm gonna say at least 3 numbers and use the easiest 3 numbers. So normally we go from -2 to +2. You're gonna go from -1 to +1, okay? So -1 to +1, you plug it in. and hopefully you get, what would that be? So -1, you get 1/2. 1, you get 2, and then, or sorry, 0, you get 1, and then 1, you get 2, right? Okay, so let's do this part. And you can actually do this first before you even do any plugging in. What happens here? What is that +1? It's a horizontal left 1. So I like to write it like this, x minus 1, because x is lie, remember. And then the vertical shift is down 3. I like to write it like this. I think it's better, y minus 3. Okay, why do I write it like that? Because it tells you exactly what to do with your original numbers in your t-chart. Because if I have to go x minus 1, I look at my x values, I subtract 1. And then y minus 3, I look at my y values and I subtract 3. So now I have x values and y values that are new that I'm going to graph. Don't forget that you always have a horizontal asymptote, and your horizontal asymptote is going, usually y equals 0. So in this case, if you just look at, like, this would be y equals 0, but then this would be a downshift of 3, so y equals -3. Okay, so graph your horizontal asymptote first, graph the 3 points, and you should see a nice looking exponential graph. Okay, let's do another one similar. So the first thing you want to do for this is put it in order. So put it in order. Let's see if it matches. So it looks something like this, right? If you put it in order. And normally we don't have a negative x power. So we want to change that to a positive x power. What does that mean here? It gets flipped. So we see the -2, and then this is actually a 1/2 to the x power, and then +1. So now it's in the right order, where we have, like, you know, the vertical stretch, and then we have the number at the back. That's our vertical shift. Okay, so let's do the parent function, which is obviously 1/2 to the x power, and then let's list. So what comes first here? The negative, and then the 2, and then there's a +1. So what is the negative? The negative is a reflection over the x-axis. That's a -y. So when you reflect over the x-axis, it goes from here to here. So positive y, negative y, right? Okay, what was next? The 2. The 2 is a vertical stretch of 2y. The 1 at the end is a vertical shift of +1. So again, I would write y plus 1. Okay, so then you do your little xy from -1, 0, 1, and then go ahead and plug in, and then cross so that you're going to make all your y's negative. You're going to multiply them by 2. Do it in this order. It has to be done in this order. And then you get something like that, right? So I made all of them negative, and then I multiplied by 2, and then I added by 1. And then horizontal asymptote is +1. Y equals 1. I draw my 3 points, and then I have my nice looking curve. If you don't draw the asymptote, what will probably happen is you'll extend this past the asymptote, which would be incorrect. Okay? Okay, so the last part of this has to do with the number e. So e is a number, just like pi is a number, e is a number. It's very important, especially when you get to, I want to say, like, calculus, but also in algebra 2. Remember you had all those, like, compounding things? So that has to do with e, like continuously compounding, a lot of money stuff. This is technically how you would find e. So e equals this as n approaches infinity. So this is what it looks like. Okay, as n approaches infinity, what does this equal? So basically, if I plugged in a 10 and a 10, I wouldn't be very close to this. But if I plugged in 100 and 100 and put that into my calculator, so 1 plus 1 over 100 to the power of 100, I would get pretty close to 2.7. If I plugged in 1,000, then again, it would be like 2.7 something, okay? So e is just a number, like pi is a number. Okay, so how do you graph? You literally just use 2.7 for e. So, you know, -1, if that's e, then you just put e, and then if you have to multiply by 2, you just do 2e, and then later you can be like, oh, this is 2.7 times 2 is basically 5.1, 5.2, something like that, right? Or times 2 is like 5.4, sorry. So something like that. So you're using 2.7 and you're rounding kind of in your head. You shouldn't need a calculator to do this. All right, so if you're using E and you're like, oh, I need to use 2.7, I need to divide by 3. No calculator. You should be able to do it in your head, and I'll kind of talk about it as we go. All right, solving exponential functions. So then now getting into solving. So the graphing, you just do it the same way. I'll give you a hint, by the way. So let's say you have like, x, y, and then you have -1, 0, 1. Let's say this is E, so you put 2.7. Let's say you have to multiply all of these by 1/3. So if you get 2.7 over 3, that's approximately like, I'm going to say like 0.9. So you know what I'm saying? So basically you're going to just approximate. You're like, oh, this is a little less than 1 basically. So I'm going to say 0.9. Even if you said 0.8, it's fine. It's a graph like this. You can barely tell, okay? Okay, so solving exponential functions. All right. Let's say you get something like this. How would you solve it? You already saw. You use the same bases. What is the same bases? Well, there's 2 ways to do it. You can say 9. So 9 to the power equals 9 to the power of -2. Or you can go all the way to 3. So 3 squared is 9. And then you have the quantity x plus 1 equals 3 to the power of 4 would give you 81, but it's on the bottom, so it's a -4. Why is that helpful? Because now I can just deal with the powers and set the powers equal to each other and then go ahead and solve. And then be very, very careful. You need to check your answer. So you do have to check your answer. You do have to check both sides, okay? So -3. If I go -3 plus 1, that's a -2. 9 to the -2, is that this? It is. I'm good. All right, so you do have to check your answers. Okay, last one. Let's say you have something like this. You really, really, really should do it on your own. Come on, do it, do it, do it. Same bases. So this already has a base of e. What would this be if it's just e to the power of something? That's all we want, e to the power of something. Wouldn't it look like that first, right? Isn't that true? Isn't that true? So you don't just copy me, do it first, and then you get this, because if you're multiplying by the same base, you can add the exponents. Now that the bases are the same, you can go ahead and set these equal to each other. And how are we going to solve for x? You're going to factor, because you know how to factor. How many answers do you get? You get 2 answers. You have to check both. We're going to check both to see if these are both valid answers, okay? So we don't have to check this one because we didn't really do anything to that one. We have to check this one, okay? So if I plug in 1, I get -1. And then over here, if I plug in 1, I get -1. Okay, we're good. If I check the -3, I get -9. And if I check -3 here, I get -6 minus 3, which is -9. I'm good. So both of these are valid. So we're all good there, okay? Again, for these homeworks, you do need graph paper. For the book work, you do need graph paper. So I don't remember what your assignment is, but you're going to have a bookwork assignment. I don't know what it is. And then you're going to have a Delta Math assignment. So for bookwork, you need graph paper. Print out the graph paper, okay? All right, good luck.